welcome back. So earlier we discussed on system of charges, in which we are going to have, if we have many charges, so and we want to calculate the force with respect to the neighboring charges. So and we discuss how we can do that. Now we are going to solve example on it. Now let's assume we have this question. And we are asked to calculate the net force on the charge Q3. So with respect to the neighboring charge, that is the Q1, the Q2, and the Q4. Now to do this, what are we going to do? We have to, the first thing, in the previous video I said that we have to consider the direction. The direction is very important. So anybody can solve this question, but we can have different answer if we did not, if the person, there can be different answer if we did not get the direction right. So now, this time we have negative charge and we have negative charge. And we have to calculate the net force with respect to what? The Q1, the Q2, and the Q4 with respect to this theory. It means that there will be what? The force of attraction or repulsion between here and between Q3 and Q4, between Q3 and Q2, and also Q3 to Q1. Now, but here there is negative and negative charge. The direction of the charges should be what? Since this one will repel this one, then it will move in this direction. Here we are going to have Q3 and Q2. Then this charge, it will attract this in this direction. And also we have negative charge and we have positive charge. Then there is going to be what? We can cut it into diagonal into two. Then this negative and this positive will also attract this. Now we already understand our direction like this. Then we can find the force of, it means we have to find F32, F34, F31. These are what we need to find. Then we know that the distance between here and here is this. The distance between here and here is 40. Then we have to find the distance between F3 and F1 also. So if I bring this triangle out, here we have 30 centimeter, here we have 40 centimeter. Since this side is equal to this side, then this place will be equal to what? Let's call it x. Then x will be equal to the square root of 40 square plus 30 square. This is what we call hypotenuse triple. So when we have 3, 4, we are going to have 5. So let me cross check. 40 square plus 30 square. So we are going to have 50. Now, we already know that this is 50 centimeter and we need to actually convert it into meter. Now start with F32. F32, from our formula we know that Q1 Q2 over R square, which is 9.09 times 10 exponential 9 multiplied by 3 times 10 raised to power minus 6 times Q3 Q2. Then the Q2 is what? 3 times 10 exponential minus 6. Then divided by 40. If I convert 40, I'm going to have 0.4 square. This is for F32. For F34, I'm going to have the same formula. Let me just 9 times 10 raised to power 9. 9.0. Is it 9.09 or 9.0? 9.0. It's like 9.0 times 10 raised to power 9 times 10 raised to power 9 multiplied by, now Q3 and Q4. Q3 is still 3 times 10 raised to power minus 6 multiplied by 4 is 2 times 10 raised to power minus 6 divided by the distance between them is what? Q3 to Q4. We have 30, which is 0.3 square. We are going to have. Then for the third one, F31, 9.0 times 10 raised to power 9 multiplied by 3 times 10 exponential minus 6 times we have 2 times 10 exponential minus 6 divided by, then the distance between here, we say it is now 50 centimeter, which is 0.5 square. If I press this thing, this one is 0.216 Newton. So for F34 we are going to have what? .6 Newton. Then for this one we have 9 times 10 exponential 9. .50625 Newton. So these are the force. Now we need to calculate the net force. So let's consider our direction. We know that this one is moving downward like this to the negative axis, and this one is moving to the negative axis, and this one is moving upward like this. Now before okay, let's just do it. Normally from our knowledge, resultant force. So because we are going to need resultant force here. So let's say we have a force like this. We have a force here. Let's say the force is 20 Newton. And here we have angle 30 degrees. So if we want to know the horizontal force and the vertical force, clearly we can resolve this force into two directions, horizontal and vertical. Our f of x will be equal to what? Anywhere the angle is facing, we are going to have f sine 30, and here we are going to have f cos 30, which is the same thing as 20 cos 30. Also, our fy is 20 sine 30. So it means, because we did not know, we just know that this one is what? Is the intermediate between the x and y axis. So we resolve it into both vertical and the horizontal. Now let's assume that we can also have another thing. Let's say we have originally we have 30 Newton, we have 60 degrees here. Originally in the x axis, let's say we have a force here before, which is 20 Newton, and it is moving in this direction. Let's say in vertical axis also, we have a force here which is moving toward the negative axis. Let's say it is also 20 Newton. So what will happen? What will happen to the horizontal force and what will happen to the vertical force? Now we have to resolve this force into both horizontal and vertical. If I resolve this into the vertical here, I'm going to have 30 sine 60. Then the opposite will be what? 30 cos 60. But originally there is a force in this horizontal. Then I'm going to consider the two together. It means f of x will be equal to f of x1 plus f of x2, depending on the direction. Here, since this one is moving, the orientation of this is moving toward the positive direction, I will just say that 20 plus 30 cos 60. So then for the fy, we are going to have fy1 plus fy2, which is the same thing as fy1. What is our fy1? Here we have 20 Newton. But if you look at this arrow, this 20 Newton is pointing toward the what? The negative direction. Actually, we are going to have minus 20. If we consider this direction, then plus fy2, then our this resultant 30 sine 60. So this is how we normally find it. Then if you want to find the net force here, then we take the square of the two. So now we are going to use the same approach in solving this certain question. So let me explain this. Now, if you look at this, I can have a diagram like this. We have something like this. Let me just draw it the way it is. So this one is moving downward. F34 is moving downward like this, and F32 is moving towards this direction. F32, and we have a resultant force moving upward, which is F31. Okay, so we have to resolve this force into both vertical and horizontal. So this is f of x and this is f of y. Clearly we know that this is 90 degrees. So if this is 90 degrees, then we divide it into two equal parts. Clearly this angle will be 45 degrees and this angle will also be 45 degrees. So if I resolve the two forces into both vertical and horizontal, so what are we going to have? If I like, I can resolve through this side or this side. Now we are going to have what? Our f of x will be equal to, originally in f of x we have f32, and this f32 is what? Is moving to the negative direction. Then we are going to have minus f32, then plus f31 cos, because if this place is sine, then this place will be cos. F31 cos 45 degrees. Then for the fy is what? If you look at this one too, this first fy, it is also moving to the negative axis. Then we are going to have minus f34, then plus f31 sine 45 degrees. So let's input our value here. We are going to have minus f3. F32 is what? Minus 0.50625 plus f31 is 0.216 cos 45, which is equal to what? Also, yeah, this is f of x. For f of y, we are going to have minus, our f34 is 0.6 plus 0.216 sine 45, which is what? If I press this, minus 0.50625 plus 0.216. I have here to be minus 0.35351. Then here minus 0.44726. So if I take, I will now say the net force is equal to the square root of f of x squared, which is minus 0.35351 squared plus minus 0.44726 squared. Which is the same thing as 0.2 square, 0.2. Okay, let me just press the final answer. then I have approximately to be 0.57 Newton. So this is now our what? Our net force. So I hope we understand this. Then let me just take one more example under this. So let's say we have microcoulomb. Then here we have our Q2 to be minus 5 microcoulomb. Then our Q3 to be equal to plus 2 microcoulomb. Then the distance from here to here is 12 centimeter. Let's say the distance from here to here is also 8 centimeter. So now, what will happen? They say that we should calculate the net force on the charge Q1 in the system below. If you look at this, so this there will be what? The force between Q2 and Q3. Let's call it F. Okay, with respect to the Q1. So we have the force from here to here is what? We need F1 3, and the force from here to here we need what? F1 2. Okay. What will happen? With respect to this force, you see this one, on Q2, then we need what? F21 and F23. This is negative charge, and this is also positive charge, and we also have positive charge. This one will attract this. It will attract the positive charge, and it will also attract the positive charge here. It means that this one is moving in this direction, which is F23, and F21 is also moving in this direction. So if we have something like this, what are we going to do? We just say that our net force is equal to the one that is moving in this direction, F23 minus F21. So now we need to calculate the force. The force between F21 will be equal to what? 9.0 times 10 raised to power 9 multiplied by F21 5 times 10 raised to power minus 6 multiplied by 2 times 10 raised to power minus 6 divided by, if we convert this one into meter, we are going to have 0.08 square. Then this first two, F23, which is equal to what? 9.0 times 10 raised to power 9 times 5 times 10 raised to power minus 6 multiplied by 2 times 10 raised to power minus 6. Then the distance between them is 0.12 square. So we find the first here. If we find this one correctly, we are going to have the first here and the F23. So if we know them, then we can apply our formula. Since this one is moving towards this direction and this one is moving towards this direction, then the one that is moving in the positive direction minus the one that is moving in the negative direction. So this is where we are going to stop. We are still going to do more example under the superposition principle. So if there is any question, you can just put text it in our inbox. So and also like our page and share it to everyone. Thank you.